a low minimum frame rate. So we put a lot of focus on trying to get the gameplay experience to be, in a sense, as console-like as possible on the PC, that it just works. And Crossfire, which I'm going to talk about today, is one part of our approach to that as well. It allows 2 graphics cards in a single machine. Right. Okay, anyone else want to come inside? You're not going to be able to see the screen from in the doorway there, so if you want to come in, there are a few seats over to my left. All right, I've got the 2 things I need. I've got a nice drink of water, and I've got a half-used carrot. So let's start. Crossfire. I'm hoping that all of you will have already met the name. Crossfire is the name that ATI has for the multi-GPU solution. Now, I'm using the word multi there, not 2 GPU solution, because we are talking about this as a technology which is capable of being extended beyond 2, 4, things like that, GPUs per computer. So this is very scalable, and we're not just limiting this to 2. Another point to make is that this is a foundational technology as far as ATI is concerned. We spent a long time on this, and we spent a long time getting it right. Yeah, this is not, oh, let's just make it work a bit and get it out in the marketplace, and we'll have a response to SLI, because, you know, SLI has been a success with hardcore gamers, no argument about it, it's very popular. But we did not want simply to respond, just to be reactive and give you a system which kind of worked. We've actually put a great deal of effort over the last year or so into producing a system which is very, very robust. Now, we talk about robust, and to be honest, when the machine crashed within 10 seconds of being booted, you're going to ask why that is, if it's a robust system. This is a system which is about 3 months old. It's been borrowed from our Munich office, and it's very much pre-production. The boards themselves, the systems are in production now, and they do not have the tendency to blue screen unnecessarily. So you'll have to be a little bit forgiving. And look at the reviews, yeah? I mean, that's where you find out whether a system really works, whether it handles the situation rightly. Okay, so let's go to slide 1. Click. Yeah, I'm going to say click in between every slide, and the penalty is if Anjay doesn't skip on to the next slide when I say click, then he has to be taken outside by anyone here, and you can sort him out. Those of you who are listening carefully would have noticed that in the last couple of sentences back, I did say the word click, and Anjay didn't advance, so you now have the right to take him outside. However, it's lucky he didn't. It's lucky he didn't, because this is the slide we want. So the Crossfire system is built of 3 components. You have a Radeon Xpress 200 Crossfire motherboard. I'll go into the details of exactly what that is, what's special about it, why you'd want such a thing, not only in a Crossfire system, but in a regular gaming rig. A Crossfire Edition graphics card, which is very slightly different from the regular X800 or X850 that you might have bought over the last year or so. And then any old Radeon X850 or X800 graphics card that you might already own. So there's an important point to begin with. You don't have to match these things. When I say any old, I mean you can take any X800, including a pre-production one from us, and you can match it with a Crossfire Edition X800 and build a Crossfire system, something which is highly performant, stable, essentially close to doubling your performance, and in many situations actually doing that. Now, when you put those 3 components together, you get the very best performance. I'll show you a couple of graphs. I'm sure you're all excited to know that I'm going to show some graphs. I'm going to spend some time on the superior image quality, because we've really worked on that hard. There are 2 sides to high-performance graphics, and one of them is just frame rates. But if all you want is frame rates, that's easy. I can give you 1,000 frames a second of pure black, any game you like. But you mustn't just care about frame rate. You've really got to push on us about quality. If you think our driver isn't doing the right thing, then tell us. And AJ at the back there will be handing out business cards to anyone who wants him to rag on us for quality. If you think we have a problem with quality, we will address it, yeah? I mean, we're trying to produce a really high-quality, high-performance system here. So we've put a lot of attention into superior image quality in a way that the competition have not. Next, it works on all games. And this is where I do my kind of patter. Works on all games, Richard? Yes, works on all games, yeah? OpenGL, D3D, matter. Any game is accelerated by Crossfire out of the box. That's not necessarily the best way to run the system. We will export the equivalent of profiles on SLI. They'll come in the driver. Catalyst AI will know about the new profiles, the best way to run a game, and the game will simply run faster that way. But out of the box, every single game is accelerated by Crossfire. No exceptions. On the other hand, if you want to turn it off, you can do that. Yeah? In the control panel, disable Crossfire, you'd probably only want to do that if you're benchmarking, but you might want to do that. Powered by the Enthusiast chipset. I'll take you through what's on the Radeon Xpress 200. And flexible graphics card support. I really do mean it when I say you can take any X800 and an X800 Crossfire Edition, pair them up, and away you go. Don't have to buy from the same vendor. They don't have to have the same BIOS. You don't have to worry about whether a particular driver will work on one or the other. Use the ATI driver and you're sorted. Okay, click. So these comparisons are, because this is a system which is about 3 months old, the detail from the presentation is also a little old these days. These compare NVIDIA's 71.89 driver against the latest driver that we had at that time, the 8.151. The machine spec is at the bottom there. You can see the setup, 1600 by 1200, 4xAA, 8xAF. 3D Mark 2005. Do we make that run faster? Yeah. Do you care? Probably not. If you're an OEM customer of ours, you do care, so we have to pay attention to it. But do you actually care? Probably not. For those of you who do care, I'll show one of the game tests running at the end, but that's not really where our emphasis is. Yeah, this is not about winning on benchmarks. This is about giving really great gaming performance to you guys, to gamers. Splinter Cell. Well, if you take the two X850s in a Crossfire system, it's some 35% or so faster than the GeForce 6800 SLI. Yeah, at the time the slide deck was built, this is the fastest kind of setup you could get. And we're some 35% ahead. On Need for Speed Underground, something like 165% ahead. Sorry, 65. That's a really big margin, yeah? And in all these cases, only 3 of them, but in all these cases, SLI is actually active. This is not sleight of hand. I'm not taking a case where SLI has been disabled or doesn't happen to work in that driver or something like that. Yeah, this is just a full-on comparison of games that matter. Need for Speed Underground. I'd be surprised if no one's playing it around here over the show. Splinter Cell Chaos Theory. We have a demo of that, which is running on this machine as well, and we can see the performance. It's actually a straightforward factor of 2, 1.95 something that you get out of the Crossfire system. It really is twice as fast. And you can see that. Splinter Cell has its own benchmark built in. You can also display the frame rate. It really switches from 40 frames a second on an X850 Platinum Edition to 80 frames a second, or 79.8 frames a second. Tremendous. If you're into twitchy gameplay, you can have absolute full-on settings and get the very best out of it. Click. All right, so the technology is built by plugging these two graphics cards into the system. You take the standard graphics card and the Crossfire graphics card. Now, the Crossfire graphics card has a small compositing engine. It's hidden under the heatsink. You can't usually see it, but it's a small chip which does the job of taking the image from the two graphics cards, because they're both doing some work, and sticking it together somehow. That's a programmable unit, an FPGA at present. And because it's outside the graphics chip, that means that it does not use graphics chip performance. Yeah? The blending costs nothing. So we really can get this factor of 2. That's one of the reasons why the speed is so good. Another point to bear in mind is that because this is a programmable beast, this small chip here, we can produce improvements. We can easily improve the quality of AA, or we can come up with new rendering methods. And it's just a matter of a new driver, reprogram that chip. So it's very flexible and it's designed for the future. And certainly when I'm talking to games developers, one of the things I say time and time again is, when you look at a problem that you're trying to solve in game design, game development, then when you think about ATI hardware, think about the deep programmability. Think about the ways that we've built right down inside the chip of the best way of taking advantage of it. That deep programmability is usually fully exposed in DirectX and OpenGL, and we focus on programmability really deep rather than shallow, where it's just a matter of fiddling with the knobs and dials on the surface. Always concentrate on that depth of programmability to get the best out of it. And we've produced a highly programmable system here, which just means you'll get better results out of it. Okay, click. We have 4 rendering modes. 3 of them are performance rendering modes, and 1 of them is a high-quality rendering mode. Okay? There are 4 rendering modes. It is not the case that you can turn on and off the high-quality rendering mode at the same time as choosing one of the performance modes. You have one of these 4. You have SuperTiling, where one card displays what there is kind of the red blocks and the other one does the blue blocks, and then they're stuck together in the compositing engine and fed out through the DVI cable. You can obviously take that out to VGA if you have a an old VGA connector on a monitor if you want analog. Scales very well with performance. On average, we see something like 50% performance improvement on a game. Some games, if a game is CPU limited, there's not a great deal you can do for it. So some games show smaller numbers than that, smaller ratios. Some show higher. Automatic load balancing, and because this is built into the chips already, ever since we had the 9700, we've had this kind of ability to do tiles within the graphics chips. This kind of thing is very easy for us to do. This is the default mode on DirectX. So any DirectX game, that's 90% of the games that you play, is automatically accelerated by SuperTiling, unless the driver already has seen that game and knows that there's a better way of driving stuff. So on average, you see something like a 50% performance boost out of the driver by default. Then we do scissor the top half-ish and the bottom half-ish. If the top half of the screen happens to require less work, that's often the case where it's sky, say, then the system load balances and moves that division down. Works in D3D and OpenGL. Dynamic load balancing, so there's a small CPU cost, typically less than 1%. It's hard to measure, but sometimes you'll see a small delta there. And that works in D3D and OpenGL. I didn't mention the first one is, does anyone care about the difference between D3D and OpenGL, or do you just want to play games? Good, okay, then you do care. Oh, damn. Thought I was going to get away with it. Okay, so the difference between D3D and OpenGL, D3D, you just expose capabilities and then you render what you can, and if someone tries to do something outside the caps, you're allowed to crash. You can do anything you like in the driver. The game's got to stick to the rules. In OpenGL, the rule is different. You've got to render the right result no matter what. So we don't do this in OpenGL, because to do this would mean that we actually had to go to software rendering in some setups, and that would be hopeless for performance. So we don't offer the SuperTile mode in OpenGL. It's a difference in the kind of formal specification of what's required when you're behaving. Alternate frame rendering, although you will have seen this from SLI if you're familiar with how NVIDIA handles the situation, it's actually patented by ATI. That doesn't mean we're going to go after anyone. Yeah? In this kind of business, patents are there for defense. We're not trying to sue anyone for using alternate frame rendering, but it is a system that we patented back in the days of the Rage Fury Max. I'm sure many of you will look back on that fondly, saying, so where are my Windows NT drivers then? Rage Fury Max, not a huge success, but we were still inventing useful technology, and that's here in Crossfire. Alternate frames. So one graphics card is responsible for the even frames, one is responsible for the odd frames. You never have to give the two cards the same piece of work to do. So this is the fastest mode. There are technical problems, because I work with games developers, I come across these kind of things, where you have to be a bit careful about whether you can use this. That's why this isn't on there by default. Yeah, it's not the default for a game. But it is extremely fast. For situations where it works, and that's more than 9 out of 10 of the kind of cases that we look at, then you get pretty much a doubling of performance for a game which is graphics limited. We like that. So those are the three performance modes. The fourth mode is a super anti-aliasing mode, where the two graphics cards render the same image almost exactly the same, and then the compositing engine blends them together. And it does that in such a way that effectively you get 14x anti-aliasing. Very high quality indeed. Why would you care about that? Yeah? You're all here, I'm hoping, as hardcore gamers, people who want really twitchy responses from the system. Well, if your game's already running at 100 frames a second and I offer you 200 frames a second, are you going to be excited? You can say yes if you are. Okay, I think the answer is that, I was hoping that no one would say yes. The answer is there's no reason to be excited by 200 frames a second instead of 100 frames a second, because you can't see the difference. Your monitor almost certainly can't keep up. I did once see a Dell monitor that could do 200 hertz refresh. But a person can't see the difference between 100 and 200, not unless they're a damn sight quicker than I am, which is almost certainly all of you. So you would use this if your game is already running at 50, 100 frames a second, and that's enough for you. Now you can just have higher quality. Now, when you look through the hall at where the World Cyber, I forget what the Cyber Championships, I forget the proper title for it. There's a competition there, and everyone has the same machine. Because if you have a better machine than me, apart from the fact that you're almost certainly better than me anyway at the game, if you have a better machine, it's a significant advantage. This is the advantage, yeah? If you're playing a LAN game and you want to have better image quality where you can see people further away, you can see detail which other people can't pick up, this is a clear advantage. So you can choose quality over performance if your performance is already high enough. Click. So this is the SuperTiling. works, as I said, by one of the graphics cards doing what are in effect the red tiles in this setup. They're actually 32 pixel by 32 pixel blocks of the display. One does half of them, the black tiles on a checkerboard. The other one does the other half, the white tiles on a checkerboard. And you simply stick them together. The compositing engine doesn't have a great deal to do. It's just taking pixels. Which one shall I have, from you or from you? Nice and easy. And the display is therefore easy to compute, comes out real fast. And apart from the fact that you have to draw the same scene onto the two graphics cards, so they both have to deal with the same geometry, the render load is about half. So you really do see a very substantial improvement in frame rates typically. Something around 50% is what we see on average, and there are cases where you'll see 75 or 80% faster. Okay, so that's the fairly easy one to understand, SuperTiling. Click. One of the nice things about SuperTiling is that it does the load balancing for you. Because things tend to be distributed around the screen, maybe stuff towards the top and stuff towards the bottom, or stuff over to the left and stuff over to the right, this kind of auto load balances. It's always doing about half the work, really quite close to exactly half the work on each of the two graphics cards. So there isn't any extra work the driver has to do to balance things up. That's good. That means the driver can just get out of the way and get on with letting you play your game. No matter where in this exciting game based on having two vases, doesn't matter where the vases go, the frame rate will be nice and steady because those 32 pixel blocks are nice and small and it represents a good granularity. Click. The Super AA mode is a trickier one to understand, and there are some gorgeous diagrams on the next screen or two which had me confused for quite a while. So the idea is that ATI has what I mentioned earlier, deep programmability. We have programmability even down in where the anti-aliasing calculations take place. Now, what is the point in a pixel that should count for this anti-alias sample? Now, you can see on the top board that the 4 sample patterns, they're actually arranged the way we have it in the standard 4xAA mode. There's another distribution, which is pretty much as good. It's the one that's at the bottom. And if you take the two of them together and average the result, you get effectively 8x anti-aliasing. 4x from one, 4x from the other, effectively 8x anti-aliasing. So this is not about performance. Yeah? Both cards draw the whole frame. Nothing runs faster. It just looks better. And actually, when you come to test this, if you get a chance to play with the system, turn this on. Yeah? Be fairly aggressive with it, because it looks awesome. It's really, really impressive. And that's something that we're the only company that can do this. This high-quality anti-aliasing comes from the fact that we have that deep programmability. NVIDIA's hardware, for example, works with what's called rotated grid anti-aliasing. Those sample points are in fixed places. There is nothing you can do to move them around. So this is something that's only available on ATI's solution, this pure quality mode here. Click. And for those people who are really interested, this is mostly for very technical press. Let's try. Hands up everyone who wants an explanation of this slide, because it's going to hurt. Oh, no. Okay. I'm going to do the presentation in Finnish next time. All right, so the diagram over to the left, top left, for example, is an explanation of how the 8x AA is working. You have 8 cyan color blocks in the left-hand block of that pixel. That triplet there is one pixel understood in 3 different ways. On the left, you've got the multi-sample, thank you, you've got the multi-sample points over to the left, purely the multi-sample points. On the right hand of each triplet, cursor comes over to the right, further, that's it. On the right hand, you have the super sample anti-aliasing points. Well, in the case of 8xAA, they share the same super sample point, i.e., they both have the exact same view of the world. They just have different views of pixels. On the right-hand side, you'll see that there's an extra super sample anti-aliasing taking place. So in those 2 cases, the pixel centers are actually offset one against the other, which means that you have very slightly different views of the world. And those are averaged together by the compositing engine and stuck together to produce what is in effect the middle of that 10xAA block. Now, this is a very hard one to stick numbers on. We decided to call it 10xAA and 14xAA for want of a better number. There isn't really a very good number for this, because this is something that no other hardware has ever tried to do before, and it's a pretty radical kind of solution. It's an improvement in quality, and you can see the difference between 8xAA and 10xAA. You see it particularly where you have very close to horizontal or very close to vertical edges. Edges of buildings or doors, steps that you're going to be running up and down, that kind of thing. offsetting the pixel center gives you a significant improvement in the quality. The 12xAA, well, that's done by having 6xAA on one card, 6xAA on the other card with the same supersample sampling point, so you just get the 12 multi-sample samples. And then for 14xAA, you offset the pixel centers as well as using different multi-sample anti-aliasing. It's a bit complicated. I didn't want to do the detailed explanation of that slide because it hurts, but you asked for it. Click. So this is the explanation of it, and let's see if I got this stuff right. 8xAA is two cards rendering the same pixels. They have the same view of the world. They think the world is in exactly the same place, but they both have slightly different 4xAA patterns against one another. Okay? One set of 4 is slightly different from the other set of 4. So it's like adding the two together. The blend unit does the exact equivalent of giving you 8xAA. 10xAA works in exactly the same way. You still have the offset multi-sample sample points, but by offsetting the pixels, you get a different sampling of the geometry in the first place as well. It's that slightly different view of the world, and it sticks stuff together. If any of you are really, really enthusiastic about me spending more time on that, catch me on the way out and stop me from escaping, and I will go through it, but it's a bit painful for everyone concerned, I think. The nice thing, I guess, about it, if I just do one more point on it, is that adding in the super sample over the multi-sample, adding in that, so going to the 10x or the 14xAA, means that things like foliage and chain link fences, all those things look better. Yeah, and the technical reasons for that are quite deep in the way anti-aliasing and alpha testing work. Okay, click. So here's what you want that for. Anything with lots and lots of detail in it. There's a character out of EverQuest. I'm not sure if this is actually in the game, but it's a model, I believe, which was from EverQuest. Things like the microgeometry of the hair. Really, really fine lines which cross little bits of pixels and ought to contribute to the image. If you don't have anti-aliasing on, then you'll get, a pixel is either hair or not hair. And that doesn't look good when you're looking at something which is very, very fine-grained, much smaller than a pixel in physical size. So not only do we do anti-aliasing on that, but obviously we do the gamma correction at the same time. So this anti-aliasing is the best you can get your hands on. Yeah? And I'd invite you to compare it. Get a chance, take a look. You not only get that better microgeometry where exceedingly small things look about right, but you also get really, really smooth edges on the macrogeometry, on the edges of things, like I was saying, the stairs which are almost horizontal, the building wall. You might think they're always horizontal or always vertical, but of course if you're in the throes of dying or if you're moving around, those things are not always horizontal and vertical and therefore should be properly anti-aliased. Click. So this is a frame grab out of Half-Life 2. The very best anti-aliasing. If you actually run this kind of sequence using the 14xAA and just move around, turn off AA, turn it back on. Turn off AA, turn it back on. The difference is staggering. These wires, which look like pretty smooth lines, they're not perfect, I admit. Yeah, we're not genuinely at the stage where we're doing cinematic quality, but they are so good in this kind of image. Hello, we've gone forward now. I didn't say click. They're so good in this kind of image that you don't get distracted by these irritating things border distance, like the aerials, say, or like those wires as you move towards them. If you look for anti-aliasing, boy, oh boy, is it distracting. Yeah, and this will remove the artifact, which is actually a distraction for everyone. Look for it and you'll hate it. If you don't look for it and you're fine with it, cool. Yeah, the X300 or X700, those are the cards for you. If you're a hardcore gamer and you want the advantage in a battle so that everything that moves you really see when it moves and not when it doesn't, this is the kind of solution you want. So very, very high quality AA. Click. Quick comparison. I said it works with all games, and obviously I'm going to have some reservations here. I'm going to start listing the games that it doesn't work with. It works with all games, yeah? There are no reservations there. You can turn it off if you want to, but it really does work with every single game out of the box. Doesn't matter how old the game is, doesn't matter whether we've tested it on our driver or not, it will work unless you, the user, choose to turn it off. SLI, on the other hand, I'm sure none of you have ever heard of any of the games on the right, yeah? Let's see, Unreal Tournament 2004. It's the way it's meant to be played game. You'd think NVIDIA would have it in their driver, but it's not in the 7189 driver. I don't know if they've updated that. They may have done. Maybe they've got up to 100 games, but how many PC games are there? What about the games that NVIDIA haven't seen yet, that you haven't seen yet, yeah? I'm working with games developers. They bring out a new game. Is it accelerated by Crossfire? No. All of those games on the right, and I'd invite you to spend some time looking at the list, were not supported in the 7189 driver. Every single game, whether you've played it before or not, whether our driver guys have seen it or not, whether I've seen it or not, is accelerated by Crossfire. Click. We'll list some of the important ones. Lock-on modern air combat. Yeah, that's accelerated by Crossfire, not by SLI. Chronicles of Riddick, same thing. That's quite extraordinary, actually, especially since they advocate its use as a benchmark. Click. Counter-Strike Source. Hardly an important game. I don't imagine anyone here is playing it, yeah? Not accelerated by SLI. Click. Unreal Tournament 2004. Bewildering. It was in a previous driver, and it came out. That's really worrying, yeah? I think as a gamer, you expect the driver to get better as time goes by, to include more, to deliver more. That's not what happened with this driver. Maybe it's just an aberration, but I didn't fix the driver in any kind of way, yeah? This is just the public driver. Click. And thousands of others. Literally thousands, yeah? If you think about the numbers, with about 3,000 games available on the PC at the moment, rough estimate, but there's more than 300 that come out every year. That means that the 100 or so that they accelerate out of 3,000 is something like 3% of all games. Now, if it's every game that you ever want to play, that's cool. Yeah, SLI may be ideal for you, but remember, it doesn't cover future games at present. Click. Right, so I'll bash that really quite hard now, probably enough. Let's have a look at the benefits. This is just the benefit of Crossfire. So I said that the benefits of the kind of standard setup are somewhere around 50% on average. So Unreal Tournament 2003 is about 25% faster using Crossfire than not using Crossfire on a single X850 XT Platinum Edition setup. Go for a Return to Castle Wolfenstein, you're seeing something like an 80%, 75 or so percent increase. That's not bad at all. That's a lot faster. That's a winning advantage in a lot of situations. And Splinter Cell, almost exactly a factor of 2 faster. Splinter Cell Chaos Theory, which we've actually got on this system here, runs so close to a factor of 2 that it isn't worth quibbling about. Really, really fast. Click. On the other hand, SLI doesn't necessarily accelerate your games. The surprise is that if SLI isn't active with a game, it decelerates the game, typically by about 1 or 2%. If you're spending, I don't know, another 700 euros or so building yourself a killer system, you don't really want the games to go slower than before. I'm sure they can fix this, but that's not the point. The point is not that they can fix it, but that it shouldn't be broken in the first place. Why would a game run slower because I've spent 700 euros upgrading my system? That's unacceptable, certainly to ATI. That's why we built the system this way. All games run faster. Rollercoaster Tycoon 3. Lots and lots of copies of that sold. Unreal Tournament 2004. Oh no, SLI doesn't accelerate it, it slows it down. Chronicles of Riddick, and others too. Disappointing result. Click. Okay, so this is the kind of setup that we're recommending to you. It's got the 2 X850 or X800 kind of boards in there, one of which is the Crossfire Edition, and it has the Crossfire Edition Radeon Xpress motherboard underneath. So that motherboard is a PCI Express motherboard which has 2 PCI Express by 16 slots, 2 physical slots. If you plug in 2 cards, then they each work as a PCI Express by 8 slot, and the games run and they run fast. That's the optimum kind of setup for playing this. If you've seen some of the people who have had a chance to review systems and to tamper with them, you'll know that this isn't the only way to build a system. You could build it on the new Intel system, which is coming. I forget, is it the Intel 955, which has 2 PCI Express by 16. You can build it on an Enforce 4 if that's what you got. It all just works. Click. The Radeon Xpress motherboard itself is a very high-performance board. That'll be one of the reasons, particularly in this last quarter or so, why we've taken, I think it's 27% of the AMD market. This is a high-performance, good-value motherboard. This is not wildly expensive. You're not talking about 500 euros or something crazy for a motherboard. You've still got the CPU and memory to buy if you're upgrading. This is an Enthusiast solution, and it's very, very fully featured. Click. This is the diagram of how the Intel setup is. You can see the feature set on the board, and I don't really want to go through too much detail unless anyone's really eager. 8 USB connectors, serial ATA, as well as ATA 133, PCI slots, you'd expect them, The memory controller is built onto the North Bridge because that's the way it is with an Intel setup. AMD, the memory controller, is built onto the CPU these days, so it's a slightly different configuration. But one thing you'll notice is that we have integrated graphics in this, the Intel solution. It's not present on the AMD solution. We have integrated graphics, and you can actually connect that up as well as having a Crossfire system or just a twin DVI out X850, something like that. You can actually run, therefore, 5 displays off that system if you want to. Okay, that's not Crossfire mode. That's just, I spent too much money on monitors and I want to feel good about it kind of mode. But you can do it if you want to. And I'm guessing if you work in banks during your spare time. Anyone do that? No, not too many hands go up. But if you were, having 5 monitors around your setup might be an attractive option. For most of us, we actually want the graphics card just to be playing games and running faster, and that's cool. Lots and lots of power to it, serious system. We've also got the AC97 audio and things like high-def audio, what Intel were calling Azalea, built into it. Full-on PCI Express implementation. Click. Then some kind of fine-grained details, dual dedicated and balanced PCI Express graphics slots. So they automatically switch. You can get, if you're running both of them, 2 gigabytes a second peak bandwidth in either direction, in either slot. Yeah? If you're just using one slot, then you get 4 gigabytes a second in either direction. Standard PCI Express kind of detail. Importantly, when you plug in a PCI Express graphics card to this and then a second graphics card to it, you don't get any interference with any of the other peripherals. We're not switching off PCI to make PCI Express work or anything like that. There are chipsets that do that, and that's not necessarily an ideal solution, especially if you've got something plugged into that other connector. Very, very fully featured for AMD and for Intel. Very overclockable. Yeah, people like Sapphire and Gigabyte and others who are building these systems are building them for enthusiasts. Very overclockable. You can have it passively cooled, but also manufacturers will be giving you active cooling solutions where you'll have the chance to really push this system very hard. Click. Lots of compatibility with memory. As it says at the bottom, our engineers are enthusiasts too. I may not be a games player, and in fact, I'm not one of the engineers that they're talking about, but the guys who build these systems really want it to rock at gaming. Yeah? It's got to be really fast. It's not acceptable to build a system that's compromised in some kind of way. So we test with enthusiast memory, not just standard memory, but enthusiast memory. Things like Corsair and Crucial and Gale and stuff like that. Lots and lots. We're really careful to make sure this just works. Yeah, shouldn't be a problem. You shouldn't have to fiddle with settings to make particular memory work, anything like that. Tested with lots and lots of high-performance peripherals, so things like gigabit Ethernet cards work in there. Yeah, you can have a PCI slot or a PCI Express slot. You can use it. You can get full bandwidth out of it. We don't interfere with it. That's great. High-performance drives. If you want your game to start up quickly, you may well have moved over to SATA or something like that. Very fast. Built on 0.13 microns, so pretty overclockable. Some of these boards, like I say, will have active solutions on them, but lots and lots of overclockability in the chipset, so you can just make it genuinely run measurably faster. And you'll see that we're using Silicon Image, Broadcom, and Marvel parts in there for compatibility. And in fact, we're using Silicon Image parts in there as well for some of the basics that go on the motherboard. Because we're graphics specialists, yeah? We're not trying to tell you that we know best how to do gigabit Ethernet or something like that. We'd rather license that in, get someone who does it absolutely perfectly. We'll just work with that. We'll do the graphics side. Click. And because it's overclockable, you'll obviously need access to that overclockability. That means that you need a control panel which gives you all sorts of painful detail about how it's all set up. It's it's hyper-threading aware, so you can use hyper-threaded core. It's also multi-core aware, so you can put in the new multi-core processors from both Intel and AMD. Everything is just cool and groovy. Click. There's a nice picture of the board. It's a little bit dark on this screen. You'll see we've got things like a gigabit Ethernet. That probably matters here, actually. At least some of the systems will have to have gigabit Ethernet to get the kind of throughput that you want here. Maybe it's only the servers, but it's a perfectly good server solution. Don't need a selector card to decide whether you've got 1 or 2 PCI Express graphics cards in there. 4 PCI Express peripherals, so you have enough connectors, not just the 2x16 slots, but there's also 2x1 slots available to you. HD audio, like I said, Intel were calling it Azalea up until it was launched. High-def audio is very high quality, yeah? And I think you should get a high-quality solution if you're buying a motherboard that's supposed to last you for the next 2 years or so. No active cooling required, but things are physically arranged on the board in such a way that it's very easy for the manufacturer to put active cooling on there if they want to, and take the heat out of the places that matter most. All the MOSFETs down on the bottom left are placed there deliberately to keep the ability to overclock straightforward from a production point of view. Click. Lots of people making it. You can read that for yourself. There's not really a great deal I need to do. DFI is an interesting one, yeah. They're a new partner with this board, very, very, very much in the Enthusiast market. So I'm guessing that a significant number of you will have DFI motherboards. Click. Just a quick slide about the compatibility. I've probably beaten this one to death. Yeah, any X800, doesn't matter whether it comes from us, from Tool, from Sapphire, anyone. Put it with an X800 Crossfire Edition graphics card and a Radeon Xpress 200 Crossfire Edition motherboard, and you have a Crossfire system. You don't have to go out and buy a new graphics card to make this stuff work. Any old X800 paired with an X800 Crossfire Edition, any old X850 paired with an X850. They do clock at the same, actually they don't clock at the same speed, so if you have a fast card and a slow card, we'll let the two of them work at the fastest that they both can and do smoothing on the performance, essentially using the compositing engine for that. But if you have a 12-pipe card and a 16-pipe card, we are forced to program them both to be 12-pipe. So your best thing is to go for something like an X800 XL now and then upgrade to a Crossfire Edition X800 later on. And there's about 1 million of them out there, so 1 million people are able to step up to a Crossfire system without having to throw away their existing graphics card. Click. That's a picture of the board again. So the previous slide was about motherboards. This is about the graphics cards. One thing that you can see from that graphics card, I'm not sure if we can get the cursor over to the second DVI connector. You'll notice that there are two DVI connectors, one of which is a high-density DVI connector, the other of which is a regular DVI connector. The high-density one acts as input and output, so you can take a signal into there from the other graphics card. Comes in through the TMDS transmitter. We're all excited by that. And then you can also take output from it. So if you want to run that card as a twin-head system, you can do it. If you want to run it as part of a Crossfire system with just one output, it comes out through the main output there. Very flexible, very powerful, and about another 20 euros is the expected cost to buy the Crossfire Edition card. So not wildly expensive. Click. Quick summary of advantages and disadvantages. You won't be surprised to see that I've got yes written under the column for ATI and no written under the column for SLI. These are really important, yeah? Does it work for all games? Yes for ATI, no for NVIDIA. Do you get high-quality rendering support? Do you automatically get that higher quality anti-alias mode? Can you just have it because you want it? Can you enable it through the control panel? Yeah, we can do that. No, it's not available on NVIDIA. LAN. Have you got a flexible 10100 or 1000 setup? Yeah, is it gigabit Ethernet or 10 base T or 100 base T? The flexibility is built into our design. That's something that is an extra cost to the motherboard manufacturers if they want that flexibility in there. The Azalea audio, if you want that high-def audio, that's only an ATI solution. Monthly WICL driver updates, yeah? Are you all aware that we put out a new WICL certified driver every month? Do you care? Do you know what WICL is? If I say WICL enough times, will you care? Okay, somebody knows about WICL. Good. So WICL stands for Windows Hardware Quality Labs. Microsoft do a quality suite, a set of software that takes literally days to run on a PC, and it beats up your PC, trying to crash it, trying to trip it over, trying to make the driver fall over if it's going to fall over. And if it doesn't fall over, if it's stable, if it does what it should do, then Microsoft will ship that or will sign that driver as WICL certified, i.e., you know it's robust. Now, we put out a new WICL certified driver every month. Yeah, we work really hard. We spend many man-months of work on this every month to make sure that you get a high-quality driver every month, because we don't want your systems crashing on you in the middle of games. And we promise we'll deliver a new one every month. About the 10th to 13th or so of each month, we put a new one out. Did we put out one in July? Yeah. Will we put one out in August? Yeah. And so on, always going forwards. And our Linux drivers, we ship a new driver every 2 months. Yeah. Linux is not as important to us as Windows is. Windows is the main market that we have to deal with. But, you know, we care about all these things, and we really care about quality. Slightly lower power demands, that's not a big difference, 475 watts versus 550 watts. But if you already own a 500 watt power supply, I guess it makes a difference. You'll have to throw it away if you want to step up to SLI and then have it actually meet NVIDIA's specification. Just a 475 watts of power supply will work for us, unless your name is Aki Yarabileto, in which case the power supply gets broken, and I'll have a chat with them about that later. Multiple rendering modes, things like SuperTiling, AFR, scissor mode, all of them high speed. Well, the SuperTiling isn't available. It's on by default for us. Yeah, that's what's handling the 90% by number of played games which are not kind of profiled already. So every single game all runs SuperTiling by default, except in OpenGL where it's scissor mode. Really, really good, great robust support, just going to work for you. Click. That's a real marketing slide. Oh, actually, this is the real marketing slide, isn't it? Because it says Crossfire is, can anyone read that? The gamer's dream platform. So apologize, that really is a bit of a marketing slide. But it's very, very good, yeah? I mean, it's hugely impressive. It's the best performance, yeah? You can see that up against a 6800 SLI system. We outperform it. When we come up with a new piece of hardware, I'm betting that our next generation hardware in Crossfire mode, because it'll be there, yeah? Bet on it. I'm betting that will beat a 7800 SLI system. And I'm betting money on it, yeah? I'm betting my salary on it. I'm employed by ATI, and if ATI can't compete in this kind of market, then they don't deserve to succeed. I'm confident that we're going to win. We give you the very best image quality. If that's what you want to choose, great, yeah? If you want to play your game so that you can see absolutely everything that's going on, that's a fair choice for you. You spent the money on the hardware. Couldn't we just enable it? Good. Works on every single game. Just take it out of the box. Take an old game. Take a game that's 5 years old, and it'll just run, just work. Powered by the Enthusiast chipset, which means you've got all that overclockability, yeah? If you're interested in having an FX57 processor from AMD, the very fastest one, you're going to build liquid cooling or something crazy like that into the system. And I don't mean crazy in a negative way, yeah? I believe in this kind of stuff. I love doing it myself. This is a great solution. And very flexible, yeah? If you've already got one of our graphics cards, an X800 or an X850, up you go. No problem at all. Click. And I think at that point, I'm done. So if we skip out of this, if you hit escape and quit out of the demo, now the excitement really begins. Are we able to crash this system again in front of a live audience? Let's see what we can do. I suggest that we start off, yeah, thanks. If we run 3D Mark, just so you can see the kind of frame rates, because 3D Mark displays frame rates. Yeah, understand, this is a benchmark. This is not what we focus our attention on. Our customers, the OEMs, people like Dell and HP and so on, they care about this a great deal. But really, really, deep in our hearts, what we want to do is make games run faster. So if you can set this to 1280 by 1024, set it to 1280. So let's have the monitor setting. Change in the middle, up a bit, that's it. Change. Now what happened? Okay. It didn't do change, never mind. So I think this is probably running at 1024, 768 now. If any of you are familiar with this, then you'll probably know the kind of frame rates that your machine delivers. This is important to us, yeah? If we can't accelerate this kind of stuff, then we can't accelerate future games. So I spend some time saying, look, we don't care about benchmarks, we care about games. But this is a good benchmark because it shows you how future games are likely to load your graphics card. So we care and we don't care. None of you play this game. In that respect, none of you care about it. But it's important to us. It's a really good driver to make our hardware more performant, more high quality. All right, you can see the kind of frame rates that you're getting from it, up to 50 frames a second. I'll bet you're not seeing that on a single card system at the moment, even if it's from ATI. Okay, let's quit out of this one. And can you just hit escape, Andrzej, please? Could do or could let it finish. All right, we're going to let it finish, apparently. Andrzej's nervous that we've had one crash, so... and I share his nervousness, but in a jovial kind of way, since I'm up here in front of the lights. Any questions on this while that's going past? Because we're almost at the end of the sequence. I'll take a question, then we'll go into the next demo. All right. No questions so far. Let's Oh, yes. Okay, the default render mode in OpenGL is scissor mode, where roughly the top half of the screen is done by one card and the bottom half of the screen is done by the other. That's a very easy one for us to have a software fallback for, because all you need to do is apply a viewport rectangle which clips either the top half or the bottom half out. So it's easy for us to meet the OpenGL spec of software fallbacks without any trouble. The SuperTile mode would be a nightmare because our software rasterizer would suddenly have to know how to rasterize tiles, and you don't really want that. Yeah, let's have 1287. Yeah, that's good. And let's choose for the, yes, OK. Click on OK. And then under Select, let's choose the, Return to Proxcon. Just do the first one. And then in a moment we'll run Splinter Cell. And that'll be about the end of the hour. This one's a good one for showing why we should have turned on anti-aliasing. If you look for nearly horizontal and nearly vertical lines, that's things like the edge of the hangar door, which is going to come up shortly. I've set the brightness down a little bit on this so you don't end up seeing very much in this scene. But when the soldiers come out into the bay here, all the lines which are nearly horizontal and nearly vertical, you can see a certain amount of flickering there, which is annoying, particularly in the distance. Now, if you're up against a sniper, you need to be able to see stuff which is in the distance. These guys are going to rush outside and we'll get a good view of the hangar. Any of the flickering there is caused by the fact that I haven't turned on anti-aliasing in this, because in the end this machine was set up to demonstrate to the press, and the press want to see the biggest number. Yeah, the biggest number is what counts. Well, actually I think quality is a really fundamental thing, but here you can see that we've not got anti-aliasing enabled. You get colossal frame rates out of it, so it would be, this is really, really high load compared to games. Yeah, we don't care about benchmarks. We care about this benchmark because it's really high load compared to games. So it puts a great deal of stress on the graphics card. Those kind of frame rates you don't see from other systems. This is significantly faster than a 6800 SLI system, for example. And no problems with the rendering. You're not getting triangle dropout or anything crazy like that. It's not a bit of a compromise. Sorry about that. It's all just good. Let's see if we can bravely hit escape this time, Angie. Go on, hit escape. Go on. Come on, Angie. Come on, Angie. Oh, yes. Benchmark aborted. OK, and the last thing we'll do is show Splinter Cell. There's a time demo. Is it a batch file? I can't read what's on the screen there. Yeah, that must be Splinter Cell. Let's try running that one. So this is a version of Splinter Cell that is not available to you guys. We're working with Ubisoft on updating Splinter Cell to include Shader Model 2 support. And we've done a great deal of programming with them. Yeah, so this is in-house stuff. In fact, at one point it will even say creating Shader Model 3 stuff, because we didn't bother changing the bitmap that's loaded up at the start. But this is actually running Shader Model 2 on X850 Crossfire Edition. And this runs at roughly 40 frames a second in the standard setup and runs 80 frames a second. It's 40 versus 79.5 something. Really is just a factor of 2. Because we've gone in, we've had a look at this, we've figured out that alternate frame rendering is the fastest way of making it run. The quality will be great. Let's go with that. And I'll just let this guy run around. One of the things that you might notice if you're familiar with the Shader Model 3 path is that this looks just the same. There isn't anything you can't do on our Shader Model 2 hardware that you can do on Shader Model 3 hardware. It's a programmer's convenience, and that's not a bad thing, but the only thing it is a programmer's convenience. So this looks the same on Shader Model 2 as it does on Shader Model 3, which means that your X850 is a cracking way to play the game, assuming that Ubisoft put this patch out. Now that's entirely up to them, yeah? We're doing the code for them, we're offering it to them, and we're not charging them or anything like that, but it's up to them to put the patch out. They own this, not us. We can't distribute this. We're not claiming any kind of ownership or anything special about us here. We're just doing some work for them to show them that you could make the game look better on ATI hardware than it currently does. And all this is doing is just running through a sequence which lasts for about a minute on a Crossfire system, or about 2 minutes on a non-Crossfire system, because this is a frame-based rendering set up here. And I think he's going to shoot the light out, slide down the stairs like Mary Poppins, for all of those of you that remember Mary Poppins. There he goes. Go on, slide a bit. Yeah, and that's the end of it. Mary Poppins has gone now. Okay, so robust support for all games. Yeah, new driver from us every month. Great piece of hardware. A solution which we will apply to all future hardware as well at the high end. Yeah, this is not I've got my desktop machine and I use it for work and all I ever do is web browse. Can I get that SLI'd? Can I get that crossfired in some kind of way? No, this is for high-end gaming. Cool. So this is aimed at people who own an X800 or an X850. This is the solution we think that everyone should prefer. But then I work for ATI, don't I? Okay, at that point, thank you very much for your attention. If there are further questions, I'll be happy to take them, whether they're nasty technical questions about DirectX and OpenGL, which I'll be thrilled by, but I will handle them, or if there are just questions about availability. I can't tell you about pricing beyond the fact that it's only about 20 euros more to get the Crossfire Edition graphics card. Any old kind of questions. And if my English is too quick or too difficult, Aki speaks very good Finnish, so I'm told. At least I can't understand it when he says it to me. So we should be able to handle a dialogue no matter what. And finally, thank you very much for coming along. Appreciate your time. Cheers. Oh, I can actually see where I am. I had no idea all of you were here. I would have been frightened if I'd realised the audience was